Hi, welcome to our channel True Up. In recent years, authoritarian and dominating America has ripped off the mask of hypocrisy and slapped penalties on ZTE, Huawei, and other technological firms. We know that the US is hesitant to acknowledge China's growing might behind this heinous action. However, China has been unable to master several core essential technologies in the development of chip technology, and these core key technologies have been technically banned for a long time by Western countries. As a result, it appears doubtful that China will make more development in this sector, and the process of progress is extremely tough. As a result of the US regulations in the semiconductor sector, China's chip business expansion has grown increasingly tough. The existing chip production technology is challenging to meet China's current development, resulting in a chip scarcity. Although China is claimed to be able to expand its strength in order to overcome some problems in this regard, it will take a long time. Many individuals have thought of another means to develop, and modern chips all incorporate nanoparticles. However, the technical breakthrough of nanomaterials need greater assistance. It is impossible for China to accomplish such a breakthrough in such a short period of time. So, can China locate the quality material? What challenges has China faced in the high-end semiconductor market? How does China investigate chip development? EUV lithography equipment is a key barrier to the growth of Chinese chips in the realm of high-end processors. With ASML heading to the United States, there is little chance of depending on imports to satisfy demand, and independent research and development is the only reliable way. Tsinghua University researchers have stated that there are two directions for Chinese chips in this area. The first is to catch up in the field of classic silicon-based chips while continuing to invest in EUV and other cutting-edge manufacturing equipment research and development. The second step is to innovate and create next-generation chips such as carbon-based, quantum, and diamond chips. The world is eagerly hunting for new semiconductor materials now that the existing cutting-edge 3 nanometers chip production method has hit its physical limit. At the time, it was unclear if EUV equipment would be employed to produce new chips. As a result, the second approach is more feasible. Of course, the result is available after the exam. A final outcome has undoubtedly been attained along the path of Chinese specialists' testing. So, what materials might China employ to replace nanometers? Graphene was found by specialists throughout the long-term exploration procedure. What exactly is graphene? Graphene is a carbon allotrope composed of a single layer of atoms organized in a two-dimensional honeycomb lattice nanostructure. The term is derived from the words graphite and the suffix, indicating that the graphite allotrope of carbon includes a large number of double bonds. A strong link connects each atom in a graphene sheet to its three closest neighbors, and each atom contributes one electron to a valence band that stretches across the whole sheet. This is the same form of bonding that may be found in carbon nanotubes, polycyclic aromatic hydrocarbons, and, to a lesser extent, fullerenes and glassy carbon. Graphene has exceptional electrical, thermal, mechanical, and optical characteristics, among other things, and has promising applications in materials science, micronanoprocessing, energy, biomedicine, and drug delivery. It is expected to be a game changer in the future. Carbon-based graphene chips are thought to be the most promising new 2 nanometers processors for breaking the physical limit of 3 nanometers and continuing Moore's law. Because the peculiar geometric structure of graphene and nanotubes is relatively comparable, China may utilize graphene to create chips, and according to experimental data, the transport speed of electrons in graphene appears to be quicker than the current speed of silicon-based materials. This also implies that if graphene is utilized to create chips, the chip's performance will improve. This outcome provides unequivocal backing for China's semiconductor development. In the experimental context, transistors composed of nanocarbons operate 5 times better than silicon transistors, according to current data. When combined with efficacy, the overall performance is even 50 times that of present technology. Because of these technologies, our country's focus on the creation of graphene chips will be more promising than it is today, despite the fact that this is a brand new subject. There is no circumstance in which other countries are trapped in technology. If China develops successfully, it will open the door to China's semiconductor sector. Is this method dependable? Can China rely on carbon-based chips to outperform the chip industry? Can you even overcome the limits of the lithography machine? Carbon nanomaterials, as far as I know, are produced at a lower temperature, and they operate better and require less energy, implying easier manufacture. It can also solve the technological issues associated with 3D integrated circuits. In principle, the power consumption difference between nanocarbon-based 3D integrated circuits and silicon-based 3D integrated circuits is 1,000 times. Chip development is becoming more confident. It is conceivable for China to surpass carbon-based semiconductors if it works hard enough. Can carbon-based chips, in the current scenario, solve the bottleneck of Chinese chips? China's only hurdle in current chip development is the development of lower nanoscale lithography devices. More technical support is needed for the development of lithography machines, but the Netherlands, which now has the most strength, has been hampered by the United States, therefore China has stepped in. It is doubtful that technology will improve further in this field, but if carbon-based chips can be achieved, China will no longer need to create lithography equipment. This is a really positive step for China. Because the development of lithography machines does not necessitate R&D, it has greater strength to create carbon-based chips as a whole, and the total manufacturing of carbon-based chips and their functionalities is superior than prior chips. Performance improves with improved development, and it can now be employed in additional sectors. Although the United States technology embargo of China has had an impact, China is not disheartened and has been aggressively seeking answers. China has achieved several accomplishments in this search procedure. China, as a lithography machine maker, has also increased from 90 nanometers to 28 nanometers. Although it is claimed that it has not yet reached the world's high-end level, it has already improved. Now, if the production of carbon-based chips is successful, China will be able to gain a competitive advantage in the chip industry. After all, this is a novel concept that has yet to be tested in any other country. If China truly develops it, the advancement in this area is that China no longer has to invest time creating lithography machines. China can acquire an edge in the fabrication of carbon-based chips, and carbon-based chips consume 50 times less than present functional usage. It might be more potent whether in use or in the process of being applied. The infusion of China's entire business will get stronger and stronger using this type of chip. The precise and sophisticated arrangement of Chinese scientists will assist Chinese chips in ushering in a new turning point and totally eliminating the bottleneck challenge. Let us anticipate China's core to make an early leap, convincing some Western countries that China's development is inexorable. Thanks for watching our video. We would appreciate it if you subscribed our channel and gave us a thumb. See you.